Observatory. Today I'm going to give a presentation on basics of telescopes and what you should expect to see when you look through an eyepiece and what you should avoid when you're buying a telescope. My name is Rich Dollish, and I have been a member of the club for 10 years now, since 2014. I am one of the outreach coordinators for the club, so I arrange star parties at different off-site locations like libraries and community centers. I also run the observatory at the VA hospital in Aspinwall. I'm frequently here at Mingo helping guests with their equipment, setting up new equipment, and I can tell you that the biggest mistakes people make when they buy equipment is either buying the wrong scope, and that's on either end of the spectrum, too much or too little, or just expecting too much out of the scope they get. Just a little sidebar, this picture here is called the Hubble Deep Field. In 1994-95, the director of the Hubble telescope had about 100 hours or 10% of the time of the scope that he could do with what he wanted. They took it, they pointed it at an empty piece of sky up near the Big Dipper. They couldn't see any visible light. And they let it run for 100 hours, capturing data. This is what it produced. And every speck of light you see, except for this one with the refraction spikes, is a galaxy. So each speck of light composes billions of stars. And there's billions of galaxies. So that's the picture that got me back into astronomy from when I was a kid. So what's out there to see with your telescope? Number of things, we got a whole list here. Satellites, the moon, planets, galaxies, nebula. I won't go through them all, but many of these you can see with your naked eye. You don't need any optics at all. Many of them you can see with just binoculars. Many of them you do need a telescope, but just because you don't have a telescope doesn't mean you can't enjoy the night sky. But let's get to the meat of it. I will mention some different terms throughout the presentation. If I say something and you're not sure, please raise your hand. Aperture is simply the diameter of the optic, so diameter of the mirror or lens on the telescope. Focal length is the distance the light travels within the telescope. The next three are types of telescope mounts: equatorial mount, altitude azimuth mount, or Dobsonian mount, and I'll have more details on those in a little bit. And finally, collimation, which is simply aligning the mirrors so the light path moves correctly. Absolutely. I can send them to you. Just be sure to leave me your email, or you can grab one of my cards here. So what are some basic equipment astronomers use? Obviously telescopes, also binoculars. When I go to a dark sky site up north, say Cherry Springs, I spend equal time looking at a telescope, looking through binoculars, and just sitting in a chair looking up at the sky. So again, you don't need optics to enjoy the night sky. The reason we use optics is for light gathering. So our eyes only open up to about 5 millimeters or 6 millimeters when they're dark adapted, and that's just about the size of a drinking straw. With a telescope or binoculars, we open up to minimal for a telescope is 76 millimeters, so that's about 3 inches, up to 300 for a consumer grade telescope, which is about 12 inches. And then there's members of the club who have 16 inches, who have 30 inches. Sky's the limit sometimes. Binoculars typically go about 42 to 50 millimeter. They can also go up to 70 or 100. Now let's talk about the types of scope. So there's three basic types. A reflector, which uses mirrors to gather and focus the light. A refractor, and this is what everyone thinks about when they think of a telescope. This uses lenses to gather light, focus light. And finally, a compound or catadioptric telescope, which uses both lenses and mirrors to gather and focus the light. Put the scope on a mount, equatorial mount. Now, when we get to what I recommend purchasing, none of them will be on an equatorial mount. That's not saying they're bad. Equatorial mounts are very good. Every astrophotographer uses an equatorial mount. They're just a little complicated, more complicated than an alt-az mount or a Dobsonian mount. So with an equatorial mount, it moves the telescope in an arc to match the rotation of the Earth. So if you ever looked at the stars for a long time, you see they do move in an arc around the sky, or you've seen the picture of the North Star with the star circles around it. The equatorial mount matches that movement. Alt-az and Dobsonians simply move up and down and in a circle, left and right. For a Dobsonian, the telescope sits right here in the cradle, and for the other mounts, there's some kind of dovetail attachment, and again, but up and down, round and round. All are good mounts. Alt-az and Dobsonians are more set it and forget it type mounts. Refractors. Refractor telescopes, again, what everyone thinks of, oh, a telescope, they think of a refractor. The light comes in the objective end, which is just the end pointed out to space or to whatever your target is. Comes in the objective end through lenses, focuses out the eyepiece to your eye. They're easy to use. There's no maintenance. And when you put a diagonal in, which is that little 90-degree piece at the end, you can use them for terrestrial viewing. It makes the image upright, so you can use it for bird watching, wildlife, etc. You see them on alt-az or equatorial mounts, but there are some negatives to them. First of all, there's no such thing as a good budget refractor. They just don't exist. They use cheap lenses, it gives you a poor image, and it has what's called chromatic aberration, which means, everyone remember a prism in school? You shine a light, breaks it up into the waves. That's what the lens does. It breaks it up into its individual light waves. But it can't focus all the waves at the same point. So when you look at a bright object, you get a little halo around it, either red, blue, purple. That's called chromatic aberration. More expensive refractors use additional lenses to cut back on that. So that's why a good refractor costs a lot of money. Not a lot of money, but much more than what you would expect for a gift. Also, the large aperture refractors are also very expensive. Lenses are more expensive to make than mirrors, basically what it comes down to. Reflectors. Reflectors, the objective end is here, the light comes in, bounces off a parabolic mirror at the bottom to a secondary mirror up the top, and then it shoots it out the eyepiece to your eye. These are the best value. most aperture for the money. They're great wide views for deep space objects, for galaxies and nebula. They don't have chromatic aberration, but when you're looking at stars, you get refraction spikes because of the mount for this secondary mirror. It's called a spider, and it has normally 3 or 4 vanes that hold that in the center of the telescope. So you get little spikes on stars. Can be used on all 3 types of mounts. Again, pros and cons. So it's a big open tube. So it's collecting dust, it's collecting dirt. Every spring when I open mine up, there's a spider nest in there of some kind. They do require collimation. That again was the alignment of the mirrors. So this mirror has to align properly to shoot the light to this mirror, and this mirror has to align properly to shoot it out the eyepiece. Not a big deal. Once you get it set, it only takes maybe 2-3 minutes. So it's nothing to worry about, but it is something you have to, be aware of. They also, the larger ones, require a certain amount of cool down or acclimation to outside temperature. You look down the highway and saw heat waves coming off the road. If you store this in your house, in a warm house, and take it out into a cool night, you'll have heat waves coming up out of the tube, and that will distort your view. So you just set it up for a little bit, let it cool down. They can be big. Good. Yes. No, the focal length is the distance from the mirror to the secondary mirror to the eyepiece. It doesn't count coming down. They can also be big. So I have a 12-inch reflector, Dobsonian, and it's frequently called a hot water tank. So if you're something you have to carry or transport, keep that in mind. Finally, the compound or catadioptric. They're excellent compromises between refractors and reflectors. Good for solar system or deep sky. They're very compact. An 8-inch Cassegrain is going to be about that big, where an 8-inch reflector is going to stand about that big. So nice and compact, easy to carry and transport. Typically on an alt-az or equatorial mount. They also require collimation. For this, the light comes in, this is a corrective lens here. The light comes in the front, reflects off the primary mirror in the back, again up to a secondary mirror, and then down through the tube, through the primary mirror to the eyepiece. So again, these mirrors need collimated. A little, maybe one more step with a compound scope than a reflector, but it's still not a big deal, just something you need to be aware of. They are more expensive per inch. There's water in the back there if you need. They're more expensive per inch than reflectors, but still very good deals. The biggest negative, in my opinion, is that they're big dew collectors. So this is just a piece of glass up front here, and as the night cools and dew forms, it settles right on this glass. So you'll see either people with a dew shield, which is a piece of foam or plastic wrapped around the end of the tube, or what's called a dew strap, which is just a piece of cloth with some wires running through it. Low voltage goes through it, it warms up the scope to prevent dew. That's your 5-minute overview of telescopes. Let's talk about what you should look for when you want to buy a telescope. More importantly, we're also going to talk about what you should avoid. Now, this is geared toward visual astronomy. I am a visual astronomer. It's what I know. If you want to get into astrophotography, John is an astrophotographer. Marcus out front is an astrophotographer. They can help answer your questions if you have them. There's no such thing as what you would consider a budget astrophotography setup. Now, a budget telescope can be under $300. Budget astrophotography rig is probably going to be about $1,500. So just keep that in mind. Also want to say, there are bad scopes, but there are no unusable scopes. So if you already bought a scope similar to this, bring it down to a star party. I will help you see the moon. I will help you see the planets through your scope. Don't throw it away because you think, oh, he told me not to get this one. It's junk. No, you'll be able to see something. It's just more challenging to use. So what's most important to look for? What's not? Stability, aperture, which again is the diameter of the scope, and ease of use. Stability is most important. If you have a shaky mount and it wobbles, by the time it's done wobbling, that's going to be magnified through the eyepiece and you'll never get a good image. Smaller the aperture, the less you're going to see. So you want as much aperture as you can afford. That will let you see more. Ease of use. If you have the most expensive scope in the world, but you don't know how to use it, or it's too complicated to set up, you're just not going to use it. I got a treadmill in my bedroom that hangs clothes, so, you know. What's not important? Magnification. If you look on this box here, first thing above terrestrial astronomical telescope is 50 power. You don't want to buy a telescope based on whatever it says the magnification is. That's typically an overinflated number. That with multiple accessories or best for beginners, they're all marketing terms to appeal to your psychology. Nothing to do with astronomy or telescope. So hobby killers. This is what we call a scope that someone buys, they try once, they get frustrated with, and never use it again. They're sold as beginning scopes. They have a cheap shaky mount with poor connection point. They have a bunch of accessories that are useless. They advertise too much magnification. And then, like I said, on the other side of the spectrum, it's too big or it's too complicated. If you go to, and you don't want to do this, but if you go to your favorite shopping site and type in the search, best beginner scope or beginner scope for teens or beginner scope for adults, you will get pages and pages of scopes that look like this. This is on there, it's under $100. It's also on there for $50 for basically the same scope, just a different vendor. It has cheap spindly legs, so it's a weak tripod. It has a poor mount to the telescope, so the scope will vibrate. It has a finder scope that's very difficult to aim. Finder scope is one of the most important parts of the scope because it's how you find the targets in the sky. Can't aim it properly, can't find any. This one has a cell phone mount and a Bluetooth remote for your phone. Because if you put your phone on that telescope, touch the screen to take a picture, you can go and get a cup of coffee, come back, and it'll still be shaking. That's why they give you the remote, so you don't have to touch it again. Eyepieces that are non-standard or just inexpensive. Standard astronomical eyepieces for telescope are 1.25 inches or 2 inches. One like this, it has 0.965. So they're not standard. They're very narrow field. They're just not a good eyepiece. The best thing about this telescope here is the little carrying bag it comes with. You could probably use that for, an overnight bag or something. Also, the inexpensive refractors like this, they put a field stop halfway down the tube, which is a metal plate with a smaller hole cut out of it. So they're blocking the amount of light that comes in because that will sharpen the image you see, but it's also cutting the light. So it's counterintuitive. This is the most infamous hobby killer in astronomy, and a lot of people buy it. It's made by a good company. It's called the Celestron Astromaster 114 EQ. But it's a menace scope. First, it's on an EQ mount. And I said they're not great for beginners because it's just something extra you have to learn. You mentioned the focal length, Dave, from how it transmits. So I said it goes from the bottom of the mirror here up to the eyepiece. Okay? So for this one, it gives a focal length of 1,000 millimeters, or 39 inches roughly. So you would expect that tube to be roughly 39 inches, give or take, in that ballpark. I went on Celestron website. The tube length, top to bottom, is 15.6 inches. So how do they get the 1,000 millimeters out of that? They put a lens here in the focuser, and it bends the light and gives them that increased focal length. They do that because when you put an eyepiece in, that's how you calculate your magnification. So a 10 millimeter eyepiece in a 400 millimeter telescope, which was the 16 inches roughly, is 40 power. The focal length divided by the focal length of the eyepiece gives you your magnification. If you put that same 10 millimeter eyepiece in a 1,000 millimeter focal length, you get 100 power magnification. So that's why they do that. They're increasing the magnification with a trick. It just bends the light. So that's all a lens does. If you were looking at like a magnifying glass, it bends the light, increases magnification. That's all it does. And it's a spherical mirror, and between those two things, it makes it very difficult to collimate this. To align the mirrors, so the focal length, so the light focuses out the eyepiece properly. So if you look through a reflector that's not properly collimated, you will see the stars have tails on them. It's called, well, it's just miscollimation. So they'll have tails, they won't be sharp. Or they'll have, if you take it out of focus a little bit, you should see concentric rings on a properly collimated scope. It'll be way off to the center. So it'll look like a blob here and then rings coming out this way. Mm-hmm. That's refraction spikes. That's from the spider that holds the secondary. That's not collimation. That's just something you have to deal with reflectors. So the stability is okay. It's not a bad mount. It just takes a little extra to use, a little extra to learn. If you wanted a mount like this, Celestron makes a 130 model. So instead of 4.5 inches, it's 5 inches. The 130 model doesn't have that extra lens in there. It's a true reflector. It's a good scope. I don't recommend it for beginners only because of the mount. So what do you want to look for when you're shopping for your own scope? Now, full disclosure, the first scope that I recommend a little later only meets one of these 3 points, but I'll explain that when I get there. Since we're avoiding refractors, we're talking about reflectors or compound scopes. You want to look for at least 4.5 inches aperture. You want a stable, sturdy alt-az or Dobsonian mount. And you just want some basic accessories. You want 1 or 2 eyepieces. You want a good finder scope. And a moon filter is a nice add-on because when you get a scope, that's going to be the first thing you look at. And the moon filter dims it down so it's more comfortable. So these are my recommendations. And it's based on 3 things. Budget. I have different price points. Ease of use, because again, if it's too hard, you're not going to use it. And it's going to be something that you can enjoy for years. It's something that you can grab at any time. Even the smallest of scopes you can grab on a whim, take it outside, and enjoy the view with it. Comes from 10 years experience visual astronomy, 10 years of outreach experience helping others with their equipment. It's not an all-inclusive list, and if you talk to a dozen other astronomers, they'll give you a dozen other lists. This is just based on my opinion, and if I were spending my money, these are what I would buy. So, under $100. Someone wants a telescope, you don't know if they're going to stick with it, you don't want to spend a lot of money, just want someone for a smaller child. The Celestron 76mm first scope. So it's only 3 inches aperture, but it comes on a nice, stable Dobsonian, tabletop Dobsonian mount. There's no wobble in this, no shake. Has 2 eyepieces, 20mm and 4mm. The 4mm eyepiece is garbage. I would not even put it in the focuser. 20mm eyepiece is okay. It does not have a finder scope because they figure it's small enough, it's easier to point. They have an optional accessory kit with this scope. I do not recommend getting it. It has a poor finder scope with it, and it has 2 more useless eyepieces. So if you picked up that sheet of paper out there, I recommend getting a red dot finder, and I specified one that will work with this scope, and a Plossl eyepiece, either 10mm, 12mm, that range, to complement the 20mm. That would put you, this scope runs about $75 to $80 online. With those 2 things, you're at about maybe $120, a little less, and you can get years of use out of a scope with those 3 things. Many astronomers, when you ask, they'll say, don't buy a scope at this price point, buy binoculars. And I partially agree with that. If you don't think, if you're buying for yourself and you're not sure you want to get in the hobby, binoculars are a great choice. It lets you get out, it lets you see the sky. You probably already have a pair, but you can get them for about $50 to $100. It will let you know if you really enjoy looking up. If your son or daughter wants a telescope and you hand them a pair of binoculars, they're going to be disappointed. I would have been. I would have rather had the small telescope than a pair of binoculars. So it all depends. Yes, sir. You're jumping ahead of me. So the first number for the binoculars, the 7 or the 8, is your magnification. That's your power. The second number is your aperture, so the distance at the objective end. For astronomical binoculars, I recommend 8x42, 8x50, 10x50. Anything bigger than that, and it's hard to hold stable, and then you become a shaky mount. If it's for a smaller child or a younger teen, 7x35 is good for the same reason. It's small enough they can hold it, and you can still gather enough light to see targets. If you get someone binoculars or you buy them for yourself, there's a couple books out there with binocular astronomical targets. They'll give charts on how to find them, and it's just a great resource. my, there. Under $300. Two options here, both very similar, both tabletop Dobsonian telescopes. There's one back in the corner there behind John. It's a little different. They don't make that model anymore, but it's the same concept. 5-inch, 130 millimeter, 6-inch, 150 millimeter. Again, they have a good stable base. Two eyepieces, 25 millimeter, 10 millimeter. Nice red dot finder, easy to use. These are truss tube designs, so that tube will slide down and collapse. Compact, easy to store. I actually have one of this model. I use it all the time. When I take it out, observe from home, I take it out on my deck, and I observe all night with it. It's just two eyepieces in my pocket. Set them on a stool, you set them on a table, upside down milk crate, or you can build or buy a tripod for them. Great options. And there's about a $40 difference between the two for the 5 or the 6-inch. Either way, you can't go wrong with it. These are not tracking mounts. I'll mention one tracking mount later. Most of everything I mention is manual. Under 400. So this is a 6-inch Dobsonian, classic Dobsonian. Set it on the ground. You have the tube here. Two eyepieces again, very similar to the tabletop model, just a little longer, a little taller, longer focal length. Has a 6 by 30-inch finder, which personally I don't care for. I would add on a red dot finder to this and use both, but that's personal opinion, not law. And then next we have a Celestron StarSense Explorer DX130. So this is on a tripod. Same thing, 25 10 millimeter eyepiece, red dot finder. This one has an extra feature. It has this phone cradle here on the side. This is what's called a push-to telescope. Put your phone in there, you use their app. Once you align everything, align it to the sky, it uses your phone's GPS, you pick out 3 bright stars so it knows where it is in the universe. You type in a target on your phone, and it will tell you how to find that target. It has arrows on your screen. It will direct you right to the target. I have one of these. It works well. It's just a really neat little device, to be honest with you. There are some drawbacks with this. The mount is a little shaky. It's not terrible, but there is a little vibration to it. I got used to it fairly quick. Once you're on the target and you're not focusing, it's really not going to vibrate that much. You're holding the mount steady as you track, so it's not moving. It's that little 30 seconds when you actually stop moving and focus that you get a little bit of wobble. In some cases, yes, but really you get the vibration from it being top heavy. Yeah. So there's an old trick with an inexpensive tripod where they'll hang a weight down from the center of the tripod to kind of pull it to the ground more. But the thing with this one is it's actually this part of the mount that causes the wobble. So it's just a poor design. Now for the same price point, Celestron has the same features, but it's a 114 tabletop Dob. It doesn't have that Burr-Jones design, that extra lens in it. It's a true reflector, little narrower aperture, and on a tabletop Dob. I didn't include it because I didn't want the whole thing to be Dobsonian telescopes. But it's a good option. It's the 114 millimeter tabletop Dob. They also have this one on the tripod with the 114, but that's the short scope. Stay away from it. Stay away from a 114 scope on a tripod in general. That's a good rule of thumb. There are good ones out there, but if it's on a Dobsonian mount, you're generally going to be okay, a tabletop mount. A red dot finder is about this big. It has a lens on front, and there's a laser in the back. It just shoots a little red dot on a piece of glass. You look through it, you put that red dot on your target, and if you aligned everything with your eyepiece, that's what you'll see in your eyepiece. As opposed to the crosshairs in a regular finder scope. Yes. And on the tabletop Dob back there is a red dot finder. So now, over $500. This is where you start getting into more serious equipment, more lifetime equipment. All of the scopes, you'll get years of enjoyment out of them, but if you get into the hobby, you'll want to see more, you'll want to go bigger. And then as you get older like me, you want to go smaller again because it's too hard to carry the stuff. So 8-inch Dobsonian. If you ask 100 observers, what telescope should I get? They're going to tell you to get a Dob. They say get a Dob, they mean get an 8-inch Dobsonian. Perfect balance between size, aperture, weight. It's the Honda Civic of telescopes. It's just a workhorse car. You keep it maintained, it'll go forever. This is a refractor scope. It's found them on Amazon, a couple other places. It's sold by a company called SV Bony, B-O-N-Y. It has a 90 millimeter or 102 millimeter. My text is wrong there, I apologize. 90 millimeter or 102 millimeter aperture. It runs about $300, but it's for the tube only, for the telescope only. There's no eyepieces, there's no mount, there's no finder scope. When you add all that on there, you're up over $500 for a good mount, a good finder scope, and some decent eyepiece. It can be switched between mounts, so you can put it on an EQ mount, you can put it on an alt-az mount. You could even mount this scope on a camera tripod, but I do not recommend it because camera tripods aren't designed to move like a telescope tripod. And if you do want to get into astrophotography, you could use this scope for that. You're still going to deal with the chromatic aberration, but you could use this for astrophotography. The go-to scopes. Celestron 4SE. It is a go-to tracking telescope. Runs on 8 AA batteries, which you will pretty much have to replace every time you use it. Or you can get a DC cord with an external power pack, or even an AC cord if you're close to a power source. Set it up, level the base. Using the keypad there on the side, it comes off, there's a cord attached. You enter your location, Pittsburgh, PA. You enter the date and the time. It will ask you to point to 3 stars. Once you get those 3 stars individually centered in the eyepiece, it knows your location. If you've done it properly then, you pick a target and it just moves right to the target. You don't have to touch anything. Just wait for it to stop moving. Type in Andromeda Galaxy and it will move to the Andromeda Galaxy. And then from that point on, it will follow that in the sky. So they're very handy. They're great. It's a 4-inch aperture, so it's good aperture. You can see plenty with it. And absolutely nothing wrong with the scope. It's a good scope. And it runs about $550 to $600, depending on where you're shopping. They also have a 5SE, a 6SE, an 8SE, and then in separate mounts, they'll go 9, 11, and 14. But then as that size goes up, so does the price tag. This is a new category of scopes called smart scopes. If you'll notice, none of these scopes have an eyepiece on them. They all use plate solving, artificial intelligence, and transmit the image to your phone or tablet, and they do live stacking. So C-Star S50, and they came out with a brand new model like 2 weeks ago, the S30, which is smaller. S50 runs $500. This is a company, Vionis. I've not used one of these scopes, but reviews are good. They run about $1,500 to $2,000. And the Celestron Origin is a 6-inch aperture. That runs about $4,000. Club member has an Origin. I've seen it in use. Great. The club itself has a C-Star S50. I've used it. It's great. I have some images I'll show you in a little bit. There's really nothing to do with them. Set it on the ground, the S50, I'll speak with that since that's the one I've used. Comes with a little tripod. Screw it up together, set it on the ground on a table, connect your phone to it. It uses your phone GPS. It does a little bit of warm up, and within 3 minutes, you tell it to look to a target, and it goes to the target. It goes to where it thinks it is in the sky. It takes an image to see how close it is, compares that, this is called plate solving, it compares that image to a database, knows where it is in relation to the target, adjusts itself, centers the target, and starts taking 10, 20, 30-second exposures, and then stacking them to pull out the details. Really for outreach, it's called EAA, to be technical, electronically assisted astronomy. But for outreach, for people who can't see through an eyepiece, it's really a great tool. From a visual observer perspective, it's boring as heck. It's like watching TV. I mean, but I love it for outreach. By longer exposure and stacking the. So if you get someone a telescope or you buy yourself a telescope, here's a couple books and apps I recommend. Night Watch by Terence Dickinson is an excellent beginner book. Talks about basic astronomy, talks about basic telescope, gives some targets and sky charts, how to find things, how to star hop, etc. Turn Left at Orion, same thing. Another excellent beginner book, covers basically the same topics. Binocular Highlights by Gary Soronik. This has 109 targets for binoculars. If you can see it in binoculars, you can see it in a telescope. So if you have a beginner telescope, it's also a good book for that. Free planetarium apps for your phone. Sky Safari and Stellarium work with Android and Apple. Night Sky is Apple only. Stellarium you can put on your laptop or desktop too. I use Sky Safari, Stellarium. They're great for planning observing, if I want to plan a night out, if I'm going to a different location. They're great for holding your phone up to the sky at night to identify a star or planet or something. And they're great for finding targets. Say I want to find Andromeda. I can pull Andromeda on the phone. It will show me where it is on the phone screen, and I can match the stars in the sky with what I'm seeing on the phone, and it will get me in the area to find it. That is the toughest thing new astronomers deal with, is finding targets. If it's something you can see, a star, a planet, the moon, piece of cake, because you just put it in your finder scope and it's in your eyepiece. But if you can't see it with your naked eye, then it's figuratively a needle in a haystack. You have to know you need a tool to help you find it. So we call it star hopping, or a device like that Star Sense that will guide you to. I get a lot of satisfaction out of star hopping, out of searching for the target and finally finding it. It's part of why I'm a visual astronomer. It's something I enjoy. But there are hacks you can use on most telescopes to cheat. There's apps you can use. There's what's called a setting circle that I put on all my Dobbs. It uses coordinates, sky coordinates, to put you on target. So there are cheats too. And when I'm at a star party, if I have a line of people waiting to look through the scope, they don't want to watch me find something. They just want to look through the scope. So that's when the cheats come out. So if you've spent any time researching astronomy, you've seen a picture like this. This is the Pillars of Heaven. It's in the Eagle Nebula, M16. This was taken by the Hubble spacecraft, or Hubble telescope rather, released by NASA. You will never see this through an eyepiece. Never. Don't think you'll see anything close to it through an eyepiece. It just won't happen. Our eyes do not pick up that faint color or detail. If you get into astrophotography, you can take pictures similar to this. I'm sure John has one of these in his portfolio somewhere, similar to this. But when you look through an eyepiece, you're going to see shades of gray. You're going to see white, black, and gray. That's what visual astronomy is. To me, it's the photons hitting my eyeball. So the Andromeda Galaxy is 2.5 million light years away. When I look at that, that means that light has traveled for 2.5 million years to hit my eye. And I'm seeing billions and billions of stars through my eyepiece. That's why I do visual astronomy. That's what I like. So what can you expect to see? This is the Eastern Veil Nebula. This is a sketch by a talented astronomer, Michael Vlasov. He's in Israel. He has a website called deepskywatch.com. Great little website. He took this under pristine, drew it under pristine conditions. When I look at the Eastern Veil Nebula through my scope, it's a little dimmer than this. I don't see quite as much what's called nebulosity around it, but I do see the shape. This image I took here at Mingo with the C-Star S50. It's about a 4-minute exposure. Club member Chuck J took this image. I don't know how many images or how long he had the camera on this target, but it's a beautiful image. It looks great. But again, you will never see this through the eyepiece. Pac-Man Nebula. I've looked at the Pac-Man Nebula, and this is exactly what I see through my telescope. Faint cloud, no color, shades of gray. Again, C-Star S50 out here. This is about 10 minutes of exposure. See some color. You can see a little more nebulosity around it. And then our cameraman, John Stump, took this one. John, how many exposures, how long was this? M81 Bode's Galaxy. It's M81, M82. It's a pair of galaxies. M82 is up here, the cigar galaxy. M81 is down here. And this is what it looks like through an eyepiece. I've looked at this many times. I've shown the guests at the star parties. This is what you will see. C-Star, again, about 6 or 8 minutes exposure. And then another club member took this one, Anish, took this photo. Again, I didn't ask him how long exposure, but probably comparable to what John said. This is all the same target, yeah. This is Bode, M81, M82 is by the Big Dipper. So when you look, cigars, this is the Spiral Galaxy. That's it down here. This is M82 up here. It's a great little thing, but like I said, it gets boring pretty quick.
You're a finder. I see what you're saying. But it's, I mean, really, the images.
I mean, oh yeah, the images can't be beat, and can't look through an eyepiece. It's great. When the club got the C-Star, I took it with me on vacation to learn how to use it because I figured there'd be a learning curve with it. I was wrong. There wasn't. It literally took 3 minutes. I set it on the balcony of the hotel room in Myrtle Beach, so there's a ton of light pollution. I told it to look for a globular cluster. It went right to it and started sending images to my phone. After about 3 targets, I got bored and went and got my binoculars and used my binoculars because this was just like watching TV. I mean, it was neat for the first 3, and then after that, I got bored. So, but again, that's me. That's not any of you. Jupiter, largest planet in our solar system. This is what it looks like in the eyepiece. This is through an 8-inch Dob. You can see some cloud bands. You can see the 4 Galilean moons. It's not going to fill up the eyepiece like the moon. It's going to be, you know, if you go in a little deeper magnification, this is a 6mm eyepiece, 180 magnification. So if you go up to 200, 240, you might get a little more out of it. But the more magnification, better skies you need, because it magnifies the bad as well as the good. But Jupiter is great to see. It's amazing how bright Jupiter is to see through an eyepiece. Saturn. Everyone needs to see Saturn through an eyepiece. If you don't buy a telescope, come down here to a star party just to see Saturn. You need to see it. For a small scope, you can make out the rings, but really no other detail than that. Through a medium scope, you'll see better division with the rings. You might even make out the Cassini division and maybe a cloud band. And then, what's that? You'll see typically 1 moon with the smaller scopes. Titan, the largest. It's farther off than the Galilean moons. And then with the larger scopes, you'll see a couple of the smaller moons around it. And then with the large scope, you see better definition, see the Cassini division. It's really great. Now, if you really want to see planets, and that's what you want to focus on, then you want a good refractor, because a refractor can't be beat on solar systems. The best view I've seen of Saturn was through a refractor here about a month ago. A club member had his set up, and it was just stunning. It was just absolutely beautiful. Finally, I'm not shilling for the club, but a membership to the club is a great resource if you're getting into astronomy. We have 500 members. That's a heck of a large knowledge base. You can use the grounds anytime you want to observe. We have star parties all year. We have member events only. We have an active Discord channel. We have a listserv. We have events all through the year where we can get together, talk, share knowledge, answer questions. It's $35 for an individual, $50 for a family. It's well worth it. And I'm not just saying that because, well, you get more of me, and that's something everyone needs.
You can never get enough, right?
Exactly. All right, that's the end of my presentation. I will be here for any questions you have. If you have any astrophotography questions, John will be happy to answer them. If you brought any equipment with you that you have questions on, let me know and I'll help you out with it.